So, how does the scanning electron microscope work?
Yeah, so it's basically, the theory behind it is like a light microscope. So a light microscope, you shine light on something, it magnifies it, and so you can see it better. But what the scanning electron microscope does is it uses electrons to get an image of your sample, and it can magnify up to 100,000 times. So a normal microscope can get to maybe like 400 times, but the scanning electron microscope can get much larger, 100,000 times. So once we get a picture of the particle, we then use what's called an EDS, or Energy Dispersive X-ray system, and it analyzes the X-rays that are coming off that sample. So you're sending electron beam onto the stub, and that electron beam is interacting with your samples, and there's actually X-rays that are jumping off the sample. Those X-rays are unique to the elements in the particle. So if they're like the element, like the periodic table of elements.
Right.
So if there's lead, barium, and antimony, aluminum, copper, iron, all different types of elements that you may find in a particle. But again, that lead, barium, and antimony is what we require, as well as the shape. It needs to have kind of a molten spherical shape. It's not a jagged or cubic shape.
The particle itself?
Yeah. So a characteristic PGSR particle has to be spherical or molten-like, as well as contain lead, barium, and antimony, all three. And that's what's called a characteristic particle. Some labs in America, they may call something a consistent particle. So if it didn't have lead, they may still report it as a consistent particle. But here at Boston Police, we require all three elements to call something a GSR particle.
Okay, so let me make sure I got all that down packed. So
Yeah.
The scanning electron microscope is like is like shooting electrons at the sample.
Yep.
And
Yes.
those electrons are, for lack of a better word, sticking to the particles,
Yep.
all the different types of particles, and as it interacts with those particles, it gives off some type of energy, which
Yes.
is in the form of an X-ray.
Yes. So some of the energy that's coming off is electrons, which is how we get the image.
Right, okay.
And then some of the energy is coming off as X-rays. So there's electrons popping off, and then there's X-rays coming off, and electrons coming off makes your image. X-rays coming off gives you your elemental analysis.
Gotcha.
So which it comes in the form of peaks, and those peaks are unique to each element. So we can just scan those peaks and say, okay, there's these several elements in that particle.
Oh, like a IR kind of, like
Yeah.
a FTR or
Yeah,
something like that?
Yep. It just
Right.
looks different.
Right.
Yeah, but similar kind of peaks and valleys.
Okay, that makes sense.
Yeah.
I could wrap my head around that.
It's a lot.
No, that's fine.